In this section, we're going to switch gears a little bit and go away from limits and talk about average rate of change. Now, average rate of change is probably something you've already learned about before, but we're just going to review it and make sure we have a good understanding of it. So what is an average rate of change? Well, an average rate of change is the measure of how much a function changes per unit interval. I've got this extra little 4 in there that's not necessary. Ignore that. Per unit interval. When I'm talking about a function, right, the function, how much a function changes, what am I really talking about? This is the output value, or the y value. So when you hear that, we're really looking at how does the y value change per unit interval. What am I talking about with this unit interval? Well, this is really just saying for every one x value. That word unit right here is what tells me that I'm working with just an interval of 1. And we're looking at my x intervals. So it's how a function value changes per unit interval. Well, based on that definition, we can actually come up with a good formula for how to calculate this value. And you guys, I'm sure, have seen this formula before. But if I want to calculate average rate of change, well, what I can do is I can find how much the y value changed, right? This change in my y value or my function value. And then divide it by, right? Because I want it, how does it change per unit interval? Well, how do I figure that out? Is I divide it by how much the x changed. So I divide it by the change in x. Well, in mathematics, we actually have an operation that can help me calculate a difference or a change. And that operation is subtraction. So it gives me this formula. y2 minus y1, or like my second y value minus my first y value, final minus initial, divided by x2 minus x1. That x2 minus x1 is going to give me the size of my interval, and then y2 minus y1 is telling me how much the function changed over the course of this interval. Well, what does this look like? This looks like my slope formula, right? Doesn't this look like slope? Yeah, it's the exact same formula for slope, which can help us make sense of what average rate of change really is. All average rate of change is slope for non-linear functions. Because the difference here is that if your function is not linear, it doesn't have a constant rate of change. The rate of change is not always the same. And so you can pick an interval and find the average rate of change for that specific interval. So let's look at an example here. I've got this graph down here with a bunch of plotted points and lines connecting them that measuring the unemployment rate from about 1975 all the way to about 2014. Okay, a lot of different data points. And I might ask the question, find the average rate of change in an unemployment rate. But if I just stopped there, this would not be enough information for us because this is a nonlinear function, right? I'm increasing, decreasing all over the place. It's not linear. It does not have a constant rate of change throughout. So the average rate of change very much depends on which interval I'm talking about. So in order for you to be able to answer the question, I have to give you an interval. So let me go ahead and give you an interval. From 1975 to 2014. So let's go ahead and go from beginning to end. Well, to calculate this, I'm just going to use this slope formula. But in order to do that, I need x values and y values. So what are my x values? My x values are just these years, right? Year, in my case, is my x value. So those are the x values that I'm going to use in the bottom of the function. What are my y values? Well, to get the y values, I need to actually estimate where these points are at. So we're going to go and call this 8.4, and we're going to call this one about 6.2. So using that becomes my y1, and this becomes my y2. So putting it all together, I get y2, which was 6.2, minus my y1, which was 8.4, over 2014 minus 1975. And this is going to give me my average rate of change. Let me go ahead and do this subtraction, and I get negative 2.2 over 39. What does that negative 2.2 mean? It means over this interval, my unemployment rate decreased because it's negative, decreased by about 2.2%. What does the 39 represent? 39 represents the number of years. That's the size of the interval. This is over the course of 39 years. So to get my average rate of change, I divide these numbers and I get about negative 0.0564. Once again, what's the units on this? It's percentage points per year. And there we see my unit interval, right, per 1 year. This is how the unemployment rate's changing per 1 year. So on average, I'm losing about 0.05, 0.06% unemployment rate per year. Awesome. And that's how we find average rate of change. So to recap here, in order to be able to calculate average rate of change, we need 2 points. We need 2 coordinate points, both with an x value and a y value. Now, in this case, with this example, the x values are usually given to you, but how did we find the y values? The y values, we got the y values just from using the graph. But in another situation, you may not have a graph, and instead you'll have an equation. Another way I could change up my average rate of change formula is, let me just do this with function notation. If I give you 2 different x values, then of course, the change in x is easy enough to calculate, where you can just do b minus a. But how would you get the y values? You can just plug them into the function. So you get f of b minus f of a. And that'll give you your corresponding y values for your x values. So this is another way that you can calculate average rate of change. You'll notice it's very similar to what we had before, but in order to get those y values, you can use a function to get the y values. You can plug your values into your function to get your y values. Well, let me show you another formula that we can use. And this one actually has a name. This one's called the difference quotient. And once again, this is just an alternate way to calculate a rate of change. So it's another rate of change formula, but it looks slightly different. And the way we get this one is we do f of a plus h minus f of a over h. So where does this come from? This introduces a new variable h. And what does that h represent? H is going to represent my change in x values. Or if I wanted to write it another way, it's just b minus a. It's what I get when I actually subtract my 2 x values. It's that distance between the x values. And so if we define it that way, notice what happens when I solve for b. B ends up equaling a plus h, which is exactly where this comes from right here. A plus h is effectively just b. And so I can replace b with a plus h, and I can replace b minus a with h. And so it's the same exact formula as the one above, just tweaked slightly to where the notation's a little bit different. But that's the difference quotient. I think you'll see one problem on your homework dealing with that difference quotient. But that's really the main concept behind average rate of change. So that's it for this video. Go ahead and start on the homework, see how far you can get, and then I'll do an examples video where I'll go over a couple of problems from the homework. Thanks, guys.